applications of the discriminant. Or examples. So we have an example 1. Find the values of value of k so that the equation a 2x squared plus kx minus 15 is equal to 0 has 3 as one of the roots. B 3x squared plus kx minus 2 is equal to 0 has roots whose sum is equal to 6. C 5x squared minus 8x plus k is equal to 0 has roots whose product is 1/5. Okay, here first. So for A, find the value of k so that the equation 2x squared plus kx minus 15 is equal to 0 has 3 as one of the roots. Now, if 3 is a root, it means that when x is equal to 3, the equation here must be satisfied because the roots are values of x. So you get that when x is equal to 3, it must be satisfied. So we substitute where there is x, we put 3 squared. Then here 3 minus that should be equal to 0. So we have 2/9 plus 3k minus 15 is equal to 0. That is 3k is equal to 15 minus 18, giving us 3k is equal to -3. Divide by 3, divide by 3. So k is equal to -1. Okay. B 3x squared plus kx minus 2 is equal to 0 has roots whose sum is equal to 6. So this one is not yet using the discriminant. It was a left part on the sum and product of the roots. So we know that the sum alpha plus beta is gotten as -b/a. So if it is given to be 6 and our -b is k, -k/a, which is 3 to be 6, then we are able to get the value of k. This is giving us 18 divided by -1. So get k is equal to -18. C minus 8x plus k is 0. Has roots whose sum, whose product is 1/5. Product is c/a. c/a is k/5. But we are told that the product is 1/5. Cross multiply, you get 5 is equal to 5k. divide by 5, divide by 5. K is equal to 1. So we use the fact that we understand how to get the sum, we know how to get the product. So if you're given the sum and in its formula there's a variable, you can find that variable. Question 2. Question 2. Find the range of values of K so that the equation one 3x squared minus 4k x plus k is equal to 0 will have real roots. Solution. Whenever we say real roots, that's one which was combined. Remember we said this is only possible when d, which is b squared minus 4ac, is greater or equal to 0. If it's equal to 0, we have equal. Still, we have equal real roots. If it's greater, we have real roots but distinct. So we need that combination. So what is b? B is negative 4k. We have it squared minus 4. A is 3 and C is k. This must be greater or equal to 0. So we have 16k squared minus 12k greater or equal to 0. So you factor out the k, we'll get 16k minus 12 is greater or equal to 0. Take note, whenever we have a product inequality, use the testing table. So we need to get the critical values to go to the testing table by equating each piece to 0. So this is k is 12 over 16, which is 3 over 4. So we can test. So we put 0 here. We put 3 over 4 here. A number bigger than 3 over 4 is 1. A number less than 0 is negative 1. A number in between, there's no whole number in between 3 over 4 and 0. So what we do is we add them. So adding them will get 3 over 4 and divide by 2. So we have 3 over 8. So you add 3 over 4 plus 0 and then divide by 2. And then get k, get 16k minus 12 and get k 16k minus 12. So we're testing now. When k is -1, we have a negative here, we have a negative here, so the product will be positive. When k is 3/8, we have positive here, and then 16, 3/8 minus 12, that's 1 here, 2 there, so we get 6 minus 12, which is -6. We just want the negative, so the product will be negative. And then positive here, so we get positive. So when we have greater or equal to, never make a mistake here. So take note again, pick the plus whenever you have greater or equal to, or just the greater. And pick negative whenever you have less or equal to or less. So what we have is greater or equal to. So what do? We pick the positive. So we'll say the solution set is equal to -infinity all the way up to 0, included union, including 3/4 all the way up to +infinity. So you must always use the critical values to form the solution and not the numbers you pick for yourself. You can't use this one, you just picked it. If you wanted, you could have used 100. It's also a number bigger than 3/4. Now, should we say from 100 going the other side? No. We always start from the critical values going to the other sides. That's how we obtain the solution set there. So we have landed into inequalities, and that's how you deal with them when you find them anywhere. 2, kx squared plus 4√3 x plus k is equal to 1. We have imaginary roots. To have imaginary roots, it means that you have complex roots where the discriminant is less than 0. So before you substitute, you must make sure that there's a 0 there. So this means that we're supposed to have kx squared plus 4√3x plus k minus 1 is equal to 0. So our b is 4√3. You have it squared minus 4. Our a is k. Our c is k minus 1. This must be less than 0. So this is the same as 4 squared is 16, and √3 squared is 3, minus 4k multiplied by k minus 1. This must be less than 0. So we'll get 48 minus 4k squared plus 4k less than 0. Now we have a common number 4, which can be divided because of this 0 here. So we'll have 12 minus k squared plus k is less than 0. This can be written as k squared plus k plus 12 less than 0. So the product is -12. The sum is 1. So the factors should be negative 3 and positive 4. So we get negative k squared minus 3k plus 4k plus 12 is less than 0. So we have negative k plus 3 plus 4, k plus 3 is less than 0. So k plus 3 and 4 minus k is less than 0. So we are saying critical values. Remember, we have a product again. So critical values, k plus 3 is equal to 0, giving us k is equal to 3, negative. 4 minus k is equal to 0, giving us 4 is equal to k. Then we test on a table. So we have negative 3. We also have 4. A number bigger than 4 is 5. In between 0, less than is negative 4, less than negative 3. Then we have k plus 3. We also have 4 minus k. We also have k plus 3. The final thing now, 4 minus k. So we test. Negative 4 will give us a negative here and a positive here. Since it will be 4 minus 4, which is 4 plus 4, which is 8. Then the product will be negative there. 0 will give us a positive, so you get a positive 5, a positive, negative, negative. Less than 0, so we want where it is negative. Since we said whenever you have less, you get the negative. So the solution set is going to be negative infinite, comma negative 3, not included, union 4, positive infinite. What are we taking note of? Include the critical values in the numerator in your solution set whenever you have greater or equal to or less or equal to. That's why you've seen that here we haven't included them. Here we did include them. So we had greater or equal to, we only had less. So we couldn't include.
Sir, is there a situation where the middle part, the middle set, is a solution set?
Yes. We don't. The thing is that you, if if this very question found itself to be greater, would have gone for the plus.
Okay, so it's very necessary, like, to prove it.
What do you mean to prove?
Using the table.
Yeah, it's very, very necessary because you end up picking them wrongly.
Okay, thank you.
Okay. So another set of examples on the same, so that we exhaust it fully. Should we say this was example 2 of what? Of 2. Okay. So let's do question 3. Again, find the range of values of x. Find the range of values of k for which the equation a 3x squared minus 9x plus k will touch have its vertex on the x-axis. So find the range of values of k for which the equation 3x squared minus 9k and minus 9x plus k is equal to 0 will touch for which the quadratic function, so these are not equations, let's not force it to be an equation, for which the quadratic function, quadratic function that will have its vertex on the x-axis. So what happens? When you say touch, we mean it doesn't cut. What does it do? It can only touch. Okay, it can only touch. Meaning that if it's touching like that, meaning that when you solve for x, you only get one value of x. Because it's only touching. Remember the x values that we get when you're solving the quadratic are the x-intercepts. So if it only has one x-intercept, it means that it has equal roots. So in solving this, we require that d is equal to 0, implying that b squared minus 4ac is equal to 0. b is negative 9 minus 4, a is 3, and k, this must be equal to 0. So you get 81 minus 12, k is equal to 0. So negative 12k is equal to negative 81. Divide by negative 12, divide by negative 12. So k is just one value. So you must be careful with the language. When they say touch, it does not cut. So it only has one x-intercept. So the discriminant is equal to 0 because the root is only 1 or they are equal roots. The quadratic has a repeated root. B, the same question, but now this quadratic function x squared plus 2kx plus 3 over 4 minus k will not intersect the x-axis. You guys, you've seen before that if you have the complex roots, your graph won't touch the x-axis. So what we are saying is that when the discriminant is less than 0, then you won't have the x-intercepts. So the graph will not intersect. It won't even touch. This means that we have b squared minus 4ac to be less than 0. So we have 2k squared minus 4, a is 1, c is 3 over 4 minus k. This must be less than 0. So we get 4k squared minus 3 plus 4k is less than 0. So I'm expanding there by negative 4. So we get 4k squared plus 4k minus 3 is less than 0. 4 times negative 3, we get the product to be negative 12. The sum is 4. So the factor should be negative 6 and positive 2. So 4k squared plus 2k minus 6k minus 3 should be less than 0, giving us 2k plus 1 minus 3, 2k plus 1 is less than 0. So that 2k plus 1, also 2k minus 3. So we have 2k plus 1 is equal to 0, giving us k is negative 1 over 2. 2k minus 3 is equal to 0, giving us k is equal to 3 over 2. These are critical values. So we use a table: negative half, 3 over 2, 0 is in between, 2 is bigger than that, negative 2 is less than negative half. So don't make a mistake of saying 1 is bigger than 3 over 2, because 3 over 2 is 1 point something. So if you're not good at estimating numbers, you better go far. Maybe you can use 10, because you're sure that 3 over 2 is less than 10. That's why I've used 2, because I'm sure that 3 over 2 is less than 2. And then you get 2k plus 1, also 2k minus 3, 2k plus 1, and 2k minus 3. So we have it here. Okay. Negative 2 where there's k, this will be negative, this will be negative, giving us positive. And then 0, this is positive, negative, giving us negative. 2, positive, positive, positive. Because it's less, we must get this. Your question has been answered now. Is there a time when we get the middle part? Here it is. From negative half all the way up to 3 over 2 as our solution.
Okay, sir. And yes, from the sum and the factors, when you add negative 6 and 2, does it give you positive 4, sir? How come it does work?
Yeah. So is that the switch there? Is it?
Okay, I see. Sorry.
Yeah, so it's just supposed to be a switch. So you should say plus and minus. Does it have an impact? I think it has. Let's see. The factors will be 6 and negative 2. So this must be 4k squared minus 2k plus 6k minus 3. So when you factor out, we have 2k, k minus 2k minus 1. So it will be the opposite now. And then plus 3. 2k minus 1 less than 0. So you get 2k plus 3 and 2k minus 1. I think that there's an impact there. So we have k negative 3 over 2 and k half. Perhaps we do the test. So this is negative 3 over 2 and half. 0 is still in between. And 2 is bigger and negative 2 is less. So we have 2k minus 1 2k plus 3, and then 2k minus 1, 2k plus 3. Okay. So this, that. So in -2 here, this is negative. -2, it's negative, so positive. 0, negative, positive, negative. 2, positive, positive, positive. So the solution set will just change by being switched here. So not that, but still almost the same interval. So negative, so -3/2, half. So that if they ask that this will intersect the x-axis in 2 real points, you mean that it will cut the x-axis in 2 equal points. So you're going to have 2 distinct values of x. So you solve the discriminant greater than 0. Unless there are questions. So if there are no questions to be asked, we can end here for today and proceed on Monday. So there will be no test until we finish certain coverage. So we need to finish these functions as well, just remaining here, just remaining with the polynomials, and then we'll be done. So mean that in the next class, we'll finish functions, and then we'll do binomial. We'll finish it within the course of next week, and then we'll do sets that other week. Then we'll have a test, and it will be a fully packed one. I have a standard one here. So that's why I've delayed it to come, so that it will have 3 topics. So you can feel the weight.
Okay, so.
All right.
At few there were sir.
The weight.
Mama.
So that you don't relax.
Wait,
Eh.